Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.7. Read the scenario. Determine whether each silicon diode in given below figure is forward biased or reverse biased. This figure contains different type of silicon diode configurations and we have to identify the biasing of diode in each configuration. We will start from this configuration. In this configuration, a silicon-based diode is connected through a resistance between two voltage sources. Negative terminals of both voltage sources are grounded while the positive voltage are being supplied to this diode. Now positive 8 volt is appearing across the cathode of diode while positive 5 volt is appearing through this voltage source on the anode of diode. In this circuit, we have to identify either this diode is forward bias or reverse bias. Before we make any decision about the biasing of this diode, we have to remember the conditions for the forward biasing of our diode. First condition is that the diode anode terminal should have positive connection while the cathode terminal should be connected to negative terminal of voltage source. Second condition states that the potential difference between anode and cathode of any diode should be larger than the potential barrier of that diode. In case of silicon diode, this potential difference should be larger than 0.7 volt. Third condition states that the anode voltage should be higher than cathode voltage. Now we will keep in mind these three conditions and will make a decision according to these conditions about the biasing of this diode. If we focus on this circuit, the anode terminal of diode have positive 5 volt while the cathode terminal of diode have positive 8 voltage. Now if we recall three conditions, the third condition was saying that the anode voltage should be higher than cathode voltage. But in this case, the scenario is opposite. Cathode voltage are higher than anode voltage. So we can say that this diode cannot be forward biased. So it will be in reverse biased mode. Now we will move to next configuration. In this configuration, a diode is connected through a resistance to a voltage source. In this configuration, positive terminal of voltage source is connected through a resistance with the anode terminal of diode and negative terminal of voltage source is directly connected to cathode and the value of voltage source is 100 volt, which is indicating that the potential difference between the anode and cathode of silicon diode is 100 volt, which is much higher than the potential barrier of a silicon diode 0.7 volt. So this diode will be in forward biased mode because all of the three conditions are being justified here. Move to the next configuration. In this configuration, a diode through a resistance is connected parallel to a voltage divider circuit. These three resistances are forming a voltage divider circuit. So we have to identify the biasing of this diode. In order to identify the biasing of this diode, first we have to find the voltage that will appear across this resistance 4.7 kilo ohm, because whatever the value of voltage that will appear across this 4.7 kilo ohm, due to the parallel connection, this same voltage will be appearing across this diode circuit as well. So in order to find the biasing of this diode, first we have to find voltage across this 4.7 kilo ohm resistance. For that purpose, for an instance, we will remove this diode and resistance from this network. The circuit will convert into simple voltage divider circuit. Now in order to find voltage across this 4.7 kilo ohm resistance, we will apply voltage divider rule. Voltage across this resistance will be equal to 4.7 kilo ohm multiplied by supply voltage, that is 30 volt, divided by the sum of all connected resistances in series connection. Now solve this equation to find out voltage across this 4.7 kilo ohm resistance, that will become 19.58 volt and the polarity of this voltage will be positive terminal here and negative terminal here. Now we have voltage across this resistance with this polarity. these same voltage will be appearing across this resistance and diode network with same polarity. So positive terminal of this voltage is connected to the anode of the diode while the negative terminal is connected to the cathode. And the value of voltage is 19.58 volt, which is higher than the forward potential barrier of silicon diode. So we can say that this diode is in conducting mode and it will be considered as forward bias diode. Move to the last configuration. In this configuration, a diode is connected between two voltage sources with two resistances. We have to identify the biasing of this diode. So first we will focus on the left half of the circuit. In this circuit, the positive terminal of this voltage source is connected to cathode while the negative terminal of voltage source is connected to anode. So it is clear this 10 volt source will not make forward bias this diode because the positive terminal of voltage source is connected to the cathode while the negative terminal of voltage source is connected to anode, which is the violation of first condition while biasing a diode in forward bias. So now we will focus on right half circuit of the diode. In this case, the positive terminal of voltage source is connected to the anode of diode and negative terminal of voltage source is connected through a resistance to the cathode of the diode. So this source is justifying the first condition for the forward biasing of diode. In second condition, the potential difference of this voltage source should be higher than the potential barrier of silicon diode. In this case, it is also justifying because the voltage of this voltage source is 20 volt while the potential barrier of a silicon diode is only 0.7 volt. So we can say that this diode will be in conducting mode and it will be considered as forward biased diode. So this was all about exercise problem number 2.7. Thank you. See you again in next video.